Okay, we're in chapter 2.4 of Math 113, and this is absolutely my favorite chapter or favorite section because you're actually going to see what we've been learning and apply it to real world activities. The first thing we're going to do in this section is we're going to solve right triangles. It means we're going to find the measure of all the angles, and we're going to find the sides of the measures of the sides of the triangles. So you have to think about a few little things when you're working on this because there's a lot of confusion at times. So C is not always, but in this particular drawing is the hypotenuse, capital C, and across from it is little c. And across from angle B is side little b, and across from angle A is side little a. So these are the things that you have to be careful with and you have to pay attention to. So make sure you're noticing things, especially if you have to draw your own triangle. Make sure, okay? The right angle will always be indicated, and across from it is always the hypotenuse. So it says that letter C is reserved for the hypotenuse, and most of the time that's the case in this book. So if you see side C, lowercase c is the hypotenuse, okay? So they're not going to change that on you. So the directions for this one says to solve this right triangle if A is 34 degrees and 30 minutes, and if side C, yes, side C is across from the hypotenuse, is 12.7 some units. So we need to finish out and we need to measure angle B. We know what angle C is. I'm just going to go ahead and write it. And then we need the side C equals 12.7. Side A is what we're looking for, and side B is what we're looking for. Now let's go ahead and write angle A on here too, since we already have it. Angle A equals 34 degrees and 30 minutes. So now you got a couple of ways to find angle B. First thing I'm going to think of, okay, if A is 34 degrees 30 minutes, B has to be 90 degrees somewhere in there. Or not 90 degrees, but A and B have to total 90 degrees. So if we look at that, 34.3, that actually is 0.5. So we can use your calculator and you can come up with 90 minus 34.5. So if I punch in 90 minus 34.5, we get equals 55.5. So angle angle B is 55 degrees and 30 minutes. Okay? Now, let's think about that. How can we find A, side A? So if I go across, side A is here, so side A is opposite. And then we have a hypotenuse. And then we have the adjacent side. So when we're looking at that, and I try to use the things that are given to me instead of using the things that I find. So I'm not going to go through and use what I found for the measurement of angle B. Because what if I made a mistake? Then the rest of my numbers are going to be wrong. So I'm going to be real careful. So opposite over hypotenuse is cosine. So we're going to have cosine of 34 degrees, 30 minutes, equals B over 12.7. So 12.7 times cosine 34 degrees, right, 34 degrees, 30 minutes, equals B. So B is going to equal, we're just going to round it to one place, 10.5. So side B is 10.5. Now you could use the Pythagorean theorem and come up with side A, but that means you would have to use what you found when you used B. So let's think about this. How would you find B then if you were going to try to solve for it? You have an adjacent and C, so that's the way I would do it, because you have adjacent A. Oh, I'm sorry, I found B first. So I use adjacent over hypotenuse. And so we found B, doing cosine. So let's find A using sine. I am so sorry about that. I got ahead of myself. So we're going to use 34 degrees, 30 minutes. And sine is opposite over hypotenuse. Cosine here was adjacent over hypotenuse. That is how we found side B. So now we're going to use A over 12.7. So we get 12.7 times sine of 34 degrees, 30 minutes equals A. And again, we're just going to round it to to one place. So when you use this, you're going to wind up with it being 7.2 equals A. And those are our final answers. Okay, this ends section 2.4. I'll see you in 2.5. So when we're looking at this next example, we need to go through and find everything that we're missing here. So let's look. We have all of our sides, but we don't have any of our angle measurements. So let's start and try to find angle A. So we have opposite and a hypotenuse and adjacent, just looking for A. So if we say sine of A equals opposite 29.43 over 53.58, we're actually looking for sine inverse of 29.43 over 53.58. And when we punch that in the calculator, we're going to get 33 degrees, or 33.32 degrees. Okay? So we found the measurement of angle A. Now again, you could subtract that from 90 and get angle B, but I'm a little leery about doing that. So let's go in and do angle B. So I'm going to erase these marks. And we're going to do angle B. So now this is opposite. This is still hypotenuse. But this time, this is adjacent. So now I'm going to do cosine. And since we know we're looking for the angle inverse, we can do cosine. Since we're looking for the actual angle measurement, we can do cosine, which is adjacent over hypotenuse. So you're going to use 29.43 over 53.58. And that's going to give us 56.68 degrees. Now again, you can do Pythagorean theorem, or you can do a couple of different things, but I'm not going to do Pythagorean theorem. I'm just going to go from where we are and see if I can come up with the measurement of B. How would you do that? What would be the best way? I guess I misspoke. I would use Pythagorean theorem to come up with side B. And the reason I would use Pythagorean theorem to come up with side B is simply because that would give us numbers that they gave us, not numbers that we found. So if you had 29.43 squared plus side B squared equals 53.58 squared. So let's punch that in the calculator. So if we have 29.43, we wound up with 866.1249. That's what I'm going to use on my calculator. Plus B squared equals 53.58 equals 2876.8. 0.708164 point. So then if we subtract 866.1249 from both sides, b squared equals 2004.6915, and then if we take the square root of that, b is going to equal about 44.77, whatever the units were. In this case, it was centimeters. So that is how we complete that. So we have angle A and B, and we have all the sides. So now we're going to take what we know about solving right triangles, and we're going to talk about angle of depression and elevation. And I really love this part. When I taught high school geometry, these were one of the favorite parts that I got to teach. It was always fun to me. So the first thing we're going to look at is, let's look at angle of elevation. Just think, if you're a person standing here, and this was your eye level, you're looking up. And if this is your eye level here, the angle of depression is if you're looking down. Makes perfect sense to me. So we're going to take some things and we're going to work on it and we're going to put it together. So Shelley knows that when she stands 123 feet from the base of a flagpole, the angle of elevation to the top of the flagpole is 26 degrees and 40 seconds. If her eyes are 5.3 feet above the ground, find the height of the flagpole. So this, we're looking for the whole thing. But right now, we are just going to deal with this triangle here in blue. And once we find side A, our final answer is going to be A plus the 5.30 feet. So let's think about what we have. We're looking from here, from Shelley's point of view. We have an opposite. Let's get a better color. We have an opposite and we have an adjacent. And so we have theta, which is 26 degrees 40 feet. So we're going to use tangent of 26 degrees 40 feet. You need to know how to punch that in your calculator. Equals A over 123. So 123 times tangent 26 degrees 40 minutes equals A. So when you get all said and done, and you can leave this in feet, so if you convert it to decimals, when we convert this tangent to decimal, let's go ahead and convert it to a decimal. It's going to be 26.67. That's what we're going to use. So, because our flagpole's in feet, it's not in degrees, so we don't need the degrees in minutes. So we wind up with 61.78 feet is how tall A is. But that's not what it said, so we need to go back in and add 61.78 plus 5.30, and when you get that all done, it's 67.08 feet tall. Again, that problem shows up on just about any standardized test too. So let's look at this one. You usually see these on a standardized test too. So the length of the shadow of the building is 34.09 meters tall and is 37.62, the distance, the shadow, let's say this completely. The length of the shadow of the building is 34.09 34.9 meters, and it is 37.62 meters tall. That was hard to get. Okay. Find the angle of the elevation of the sun. So let's look at all this. Let's just recap. The building actually is 34.09 meters tall, and the shadow it cast, now that makes a little bit more sense the way the phrasing was. The shadow is 37.62 meters long. So when you look at this, it's wanting us to find the measurement of angle B. So remember, anytime you're looking for the angle measurement, you're going to use the inverse function. So let's see if we can figure out what the function's going to be. So here's our angle, which is B, and we have opposite over adjacent. So that's going to be tangent inverse opposite 34.09 over 37.62. So tangent inverse is going to equal B. So tangent inverse, when you punch that in your calculator, it's going to give us 42.8 degrees is the measurement of angle B.